Day 6 of 365 was where the earlier complexity work finally started feeling tactical. Big O, time complexity, loop analysis, and the ranking of common classes are all useful, but they become much more powerful once I connect them to constraints. The useful shift today was treating input size as strategy guidance. Constraints are not just metadata at the top of the problem. They often tell me which solution families are realistic before I write a single line of code. The first big lesson was that large input usually pushes me toward linear or near-linear work. If n can be around 100,000 or more, I should become suspicious of quadratic growth immediately. That does not mean the mapping is a strict law, but it is a strong filter. O, n, and O, n log n, are often the classes I hope to see first at that scale, because they are much more likely to survive realistic constraints. Another useful shift was seeing that small input can change the game completely. If n is around 15 or 20, exponential search may be fine. That is why subsets, backtracking, bit masking, and brute force exploration still matter. 2 to the power of n looks scary in isolation, but if the input ceiling is tiny, it may be the intended and correct approach. That was a helpful correction to the idea that exponential always means wrong. That also means the real question is not whether a complexity class looks elegant on paper. The real question is whether the class fits the input limit. A quadratic solution might be totally acceptable for small n and totally unusable for large n. Exponential search might be impossible at one scale and perfectly fine at another. Constraints turn complexity from theory into a practical filter. Another big lesson was that constraints help me choose where optimization effort is worth spending. If the input is tiny, then spending a huge amount of time on micro-optimization or deep structural improvement may not matter. If the input is large, then the gap between O, n log n, and O, n squared, may define the entire problem. Constraints make the optimization target meaningful instead of vague. That is why interview problems include limits so explicitly. They are not there to be ignored after one quick glance. They are there to steer the algorithm choice. A strong solution often begins by reading the input limit, estimating the viable complexity classes, and ruling out weak approaches before any implementation starts. That saves time and leads to cleaner reasoning during the explanation. Another useful shift was that rough heuristics are often enough to guide the first decision. Large input means I want something closer to linear or near linear. Tiny input means exhaustive search may be allowed. Medium input means I need to think more carefully about constants, structure, and whether a clever optimization is actually required. These are not perfect rules, but they are powerful early filters. This also matters outside interviews. Real systems have their own version of constraints. Maybe the request volume is high. Maybe the dataset is huge. Maybe latency requirements are strict. The same idea applies. Constraints narrow the acceptable classes of behavior. Once that clicks, complexity analysis feels much closer to practical engineering and much less like a classroom ranking exercise. Another thing Day 6 clarified was how constraints reduce guesswork. Instead of trying every technique I know, I can ask what the input rules out immediately. That makes the solution search more focused. It also helps in whiteboard or interview settings because the reasoning becomes clearer. Given this limit, a quadratic approach is risky. Given that limit, backtracking is still on the table. So my main takeaway from Day 6 was that input size constraints should become one of the first things I read and use. Ask what classes the problem can tolerate. Ask whether the current approach already violates the limit, and ask whether the scale justifies brute force, dynamic programming, sorting, or a more optimized structure. If those questions become automatic, I waste less time and choose better algorithms earlier. That is what made today useful. Constraints turned into strategy. That one habit should save a lot of implementation time later too, especially in timed interviews and contests.